everybody, welcome to Monster Paper for Module 7 and 8. This is question 6. Solid sodium chloride does not conduct electricity. However, it conducts electricity when molten. Explain why solid sodium chloride does not conduct electricity, whereas molten sodium chloride does. So you can see again, this is the same question that's coming up again and again, and it's always for 3 marks. So it's always a comparison question. So you can say 1. You can start with either one. This one, let's start with solid sodium chloride. Has a fixed lattice. Ions are not free to move. For number 2, in molten sodium chloride, the ions are free to move, so they can carry electricity. So it's exactly what we wrote for a different compound before. But if ever it asks you to compare the ionic structure of the solid and the molten or dissolved, this is what you write. And don't forget that you must give a label for each one. You can't just write, it has a fixed lattice, because which one has a fixed lattice? You must be very careful about being specific there. So a concentrated aqueous solution of sodium chloride is electrolyzed using carbon electrodes. Carbon electrodes, we know, are inert. Name the products formed at the electrodes. Well, we've got Na+, and we've got H+, we've got Cl-, and we've got OH-. So out of these two, which is going to form? Of course, it's hydrogen. And out of these two, which is going to form? Of course, it will be the chlorine, because it's a concentrated solution. See how they've made that in bold? So you would obviously do that calculation, not right on the line. But we've worked out that at the anode, the anion will be attracted, so you'll get chlorine. And the least reactive of the cations will form, which in this case is hydrogen, because we know sodium is very reactive. Write an ionic half equation for the reaction occurring at the negative electrode. So at the cathode, hydrogen is forming, so H+, gaining electrons makes H2. Now, of course, because you've got hydrogen there, you need to balance your hydrogens here. So H+ and 2E- makes H2. A dilute aqueous solution of sodium chloride is electrolyzed using carbon electrodes. Name the main product formed at the positive electrode. Well, we know the positive electrode is the anode. So in this case, because it's now dilute, we haven't got very many chloride ions. So we're not going to form chlorine. What we are going to form instead is oxygen. It's either oxygen or a halogen, we know that, so it has to be oxygen that forms from the OH-. Molten sodium chloride is electrolyzed using carbon electrodes. Name the products formed at the negative electrode. Well, in this case, we don't have a battle anymore between the H+ and the Na+. We don't have the H+ anymore, so the only thing that can form at the negative electrode or the cathode is sodium metal. Remember, when it says name the product, it's what is formed. Write the ionic half equation for the reaction occurring at the negative electrode. Well, we've got sodium ions gaining an electron to form sodium metal. Chlorine is produced at the positive electrode, of course, because there's only chloride ions, there's nothing else. Give the test for chlorine. The test is that you would use litmus paper, and the result is it would be bleached. You can go white if you want to, or the colour would be bleached. So you can use any kind of litmus paper for that. It doesn't make any difference whatsoever. All litmus paper is going to be bleached. So that's the end of paper. That's the end of question 6.